Okay, guys, one more practice here. So again, we are looking at kinetics or rate. So we've got the period disulfide ion, which is S2O2 minus, 2 minus, and it reacts with the iodide ion in aqueous solution via this reaction. So we collected this data as the reaction went on. So we had an initial concentration of 0.072 molar of the I minus, and then we can see that it decreased over time. So let's answer a few questions about it. So first, we want to calculate the average rate of disappearance of I minus between 400 and 800 seconds. So we have to remember that the rate is equal to the change in concentration over the change in time. And since this is a reactant, it's disappearing. That's where our negative sign comes from. So I'm just going to pull values. I'm looking between 400 and 800, so these two parts of the graph. And anytime we have a change, it's products minus reactants. So, or sorry, not products minus reactants, final minus initial. So our final at 800 minus our initial at 400 for our concentrations, and then same thing with the time, 800 minus 400. So we end up with a 2 times 10 to the negative fifth molar per second. Part B is going to calculate the average rate of disappearance in the initial 400 seconds. So same process, but now we're going to look from 0 to 400 seconds. So we're still looking at the I minus, so our rate law is the same. Rate is equal to the negative change in concentration of I over change in time, and then final minus initial. So our final time is 400, so that was 0.057 molar. And then our initial time, we started with 0.072 molar. So our rate law is our rate is 3 times 10 to the negative fifth. So notice that initially this reaction was faster, and that's what we would expect because a higher concentration of reactants means that we're going to have a faster reaction. So this makes sense to me. The last part then is a comparing problem. So we want to calculate the concentration of the S2O8 remaining at 400 seconds. A little more information from our problem. We learned that we started with 0.050 molar. Now, if this were a one-to-one reaction, we could compare the numbers directly off of here. But since it's not a one-to-one reaction, it's a 1-to-3. So for every one of the S2O8, there's 3 of the iodine. We need to do a little stoichiometry here. So first I'm going to figure out what my change in I minus was for those 400 seconds, the first 400. So I'm going to take my final concentration minus my initial concentration, and during that time I lost 0.015 molar of the I minus. Now, I know it's not one-to-one, like I said. So if that's how much I lost of that, it is 3 moles of the iodine on the bottom to cancel iodine, and then 1 mole of the S2O8 on the top. So my S2O8 changed by 0.005 molar. Now that's not my answer. It's asking how much is remaining. So if I started with the 0.050 and I lost 0.005, I have 0.045 molar remaining of my S2O8 at that time.